Welcome everybody to today's webinar. I want to talk about speeding up the plotting procedure. So this talk does not only include the pure Western plotting procedure, but also the steps prior to Western plotting, so to enhance the speed of the complete procedure. You will also need a very fast SDS page, and so I will give you a short overview of the server products to get a very fast SDS page. So during my talk I want to go to the following points. I will give you the general aspects of plotting. Then I will show you the SDS page products for fast SDS page. I will give you an insight in symmetry plotting, the general procedures, and especially the XPressBlotting procedure. After this, I will talk about the chemiluminescence detection, how it works, and give you an example of the SERVALight Substrates. And last but not least, the documentation is also a point, so I will introduce the GeneGnome to you. So let's start. I hope it works. Yeah. So plotting, what is plotting? Plotting is the transfer of separated bio or macromolecules on an immobilizing membrane. So what is the advantage of plotting compared to the common gel staining? So as you can see on the left hand side, it's a chromatic stained gel, and you will give the complete proteins stained on this gel, but you do not get any information about what protein is especially stained or these things. But in plotting you will have a much more sensitive and a much more specific detection system because of the antibodies used. Because with the help of the antibody you can determine a special target protein, and you can answer the question whether it is present or not. So what is the aim of Western plotting? First of all, as I already mentioned, it is to confirm the presence of a target protein. And second, you will obtain a semi-quantitative information about the target protein. So after a certain stimulation of a cell line, for example, you will recognize either a down or up regulation of protein expression, for example. So the Western plotting workflow consists mainly of 5 different steps. First step is the sample preparation, followed by SDS page. After the proteins are separated, the proteins are transferred on a plotting membrane. This plotting membrane is processed by different incubation steps, first by blocking and then the antibody incubation. And last but not least, you will detect your antibodies, and you will need a documentation system to go any further. So sample preparation starts with either animal, plant, yeast or bacteria cells. You lyse the cells and you get a sample that is subjected onto SDS page gel. So, but to perform the gel electrophoresis, you will also need protein standards. There are 2 different types used for subsequent Western plotting. The pre-stained protein standards. So SERVA offers 3 new types of pre-stained markers. One problem with pre-stained markers is that they are not for exact molecular weight determination. They only allow to check whether it is in the right range, because the dye, which gives the pre-stained bands, is covalently coupled to the proteins. I'm sorry. And therefore their migration differs from the native proteins. Another possibility is a protein standard which also is suitable for immunodetection, because the marker proteins have IgG binding sites, so they interact with the antibodies used during detection, and they finally can be detected like the target protein on the blotting membrane. Furthermore, pre-stained marker bands are slightly fading through the processing of the blot, so usually the marker lane is cut off prior the blotting processing. Okay, so but to speed up your SDS page, it is possible to use, for example, the SERVA gel neutral HSE gels, where HSE stands for high-speed electrophoresis. These gels allow SDS page within 20 minutes, and the gels are available either with 10 or 12 sample wells, or also for special applications with a 2D well. We also offer a starter kit with these gels. So the kit includes 4 gels, a protein standard, sample and running buffer. So it's a worry-free kit which allows to start right away. And after this, we have also another gel type in our portfolio, where a broader range of gel types is offered. These are the so-called prime gels. Prime stands for premium resolution in mini gel electrophoresis. These gels are suitable for SDS page within 30 minutes, and they do have the same separation parameters like the lab-cast Lamley gels. So they are available as homogeneous or gradient gels. They are offered with 10, 12, and 15 sample wells, and assorted percentages of the gels are also available with a 2D well. So the samples, the marker, are loaded on the gel, and gel electrophoresis is started, and after the run you will have different possibilities to perform the plotting or the Western blotting. There are the most common are the tank plotting and the semi-dry plotting. In both methods the proteins are transferred from minus to plus, because in SDS page the proteins will get an overall load, a negative load, so the proteins are plotted towards the plus. Okay, so you have to choose the right membrane for your application. The most common types are the nitrocellulose and the PVDF membrane. The nitrocellulose membrane has a lower binding capacity compared to the PVDF membrane, but it shows low background, and the binding depends on the methanol or ethanol concentration in the blotting buffer. The unsupported type of this membrane is fragile, so today most nitrocellulose membranes are offered as supported types. The nitrocellulose is suitable for plotting proteins, DNA and RNA. The PVDF membrane, as mentioned, has a higher binding capacity. It has a good mechanical strength, so it is suitable for reprobing after stripping. It can also be used when subsequent sequencing is an issue, but it is only suitable for protein plotting. Another point is the hydrophobicity of the PVDF membrane. So it has to be activated before use, and during the processing, it is important that the PVDF membrane is always covered with the incubation buffer. Once it becomes dry, so it swims on the surface of the buffer, this will cause higher background in the subsequent detection steps. So for plotting, there are different plotting buffer systems. The homogeneous plotting buffer system is the well-known Taubin buffer. This plotting buffer system can be used for both methods, the tank and the semi-dry plotting. The other one is a discontinuous plotting buffer system, where the buffer at the cathode is different from the buffers at the anode. So at the cathode buffer, the buffer is amino caproic acid, and at the anode there are two different types of tris buffers used, where the tris concentration is different. This plotting system is recommended if proteins with different migration rate will be transferred simultaneously, because small molecules show a reduced and large molecules an increased transfer rate. So they will be transferred in a similar way. But due to the different buffers used near the anode and the cathode, this is only for semi-dry plotting. And a special plotting buffer system for the semi-dry plotting is the XPressBlotting. So I'll give you a short overview about the procedure. So before plotting, you have to prepare the plotting and equilibration buffer according to the manual. And the plotting fleece, which is very new in a plotting kit, is soaked with 20 milliliters of the plotting buffer. So the plotting fleece is included in this system to overcome the problems caused by the plotting papers. After the plotting fleece are soaked, the connection paper is wetted, and the PVDF membrane is activated by incubation in ethanol, and then it is equilibrated in equilibration buffer. And after the electrophoresis, the gel is removed from the unit, and the stacking gel is removed from the separated from the separation shell. The separation shell is then equilibrated 10 minutes in the equilibration buffer on an orbital shaker. So it is important to remove the stacking gel because it has a very low acrylamide concentration, so it is very fragile and will cause problems during plot processing, like spots on the plotting membrane. And the additional information you may get from a stacking gel will not be really helpful on a Western plotting membrane. So if you want to make sure where the sample lanes are, it is recommended to perform Ponceau S staining after the plotting. So if you have equilibrated the gel, then you can set up the plotting stack in the semi-dry plotter according to the instruction of the plotting manual, because the orientation of the stack depends on whether the cathode is on the top or on the bottom of the plotter. Then you close the plotter and place a weight of approximately 1.5 kilogram on it, and the settings for fast plotting or for express plotting are 30 volt, 400 milliamps, and 15 minutes. So this is a picture of the plotting stack. So you will see that instead of the plotting papers, there is plotting fleece on the cathode and the anode, and between the between the plotting fleece at the anode and the plotting membrane, there is so-called connection paper to ensure optimal plotting performance. So this is a special homogeneous buffer system for fast semi-dry plotting. With this buffer system and all these things included in the kit, you can also perform a slower plotting procedure by reducing the current settings to 100 milliamp. Then it will take 45 minutes. So what are the features and the benefits of this new plotting procedure and the kits? So it is a fast and efficient transfer of high and low molecular weight proteins within very short time, so within 15 minutes. The plotting fleece is used instead of several layers of plotting paper, so to reduce disturbances of the transfer, like air bubbles between the different layers of plotting papers and these things. It is ready to use, so it's not necessary to prepare buffer or cut plotting membranes or papers, and it is compatible with the most common used membrane types like nitrocellulose and PVDF. So what are the components of the plotting kit? So each kit contains sufficient material to perform 10 plots of mini shells. So this is the plotting buffer. It is a 10-fold concentrated buffer. The plotting fleece for the upper and the lower part, so these are 20 pieces, and the connection papers. We offer 3 different types of kits. One kit without any membrane, so it can be combined with a membrane of choice. So if you are used to work with a special kind of PVDF or nitrocellulose membrane in your lab, you can use this and start XPressBlotting with the upper kit. So if you want to perform XPressBlotting using nitrocellulose and you want a kit with included nitrocellulose membrane, we offer one with a 0.2 micrometer pore size nitrocellulose membrane, or we offer another one with a PVDF membrane where the pore size is also 0.2 micrometers. And to make these things complete, we will introduce our new semi-dry plotter at the Analytica in Munich. Compared to our SERVA blue flash plotters, it does not have any carbon electrodes. These are stainless steel and stainless steel plating electrodes, and it's a completely new design and new development. So if you are interested to see this new plotter type, visit our booth at Analytica. We will be on stand 403 in Hall A3. So the Western blotting, we have performed the first two steps. The SDS page, we got the gel and the separated proteins, and then we transfer the separated proteins on the membrane. Then this is followed by blocking. So unspecific binding sites on the membrane are blocked by BSA or casein or such things. After this, the primary antibody incubation follows. Then after different washing steps, the secondary antibody incubation is followed, where the secondary antibody usually has a special enzymatic label for subsequent detection. So in case this label is horseradish peroxidase, it can be detected by chemiluminescence. So how does this work? The luminol, one component in this detection system, is reacts chemically with the horseradish peroxidase in the presence of H2O2, and finally it will react and release energy which is emitted as light of a wavelength of 425 nanometers, which can be detected. So we offer several detection substrates. So depending on the requirements of your system, you can choose the optimal one. So one requirement may be the detection limit because of the expression rate of your target protein. Another point may be the dilution of your primary antibody. You have a little amount of your primary antibody, so you are forced to work with high dilutions of this antibody. So you will choose maybe the Helios or the EOS Ultra. So as the requirements will be set, you can choose the substrate which is optimal. So the next is the SERVA substrates compared to the substrates from other suppliers. So if you are interested in testing one of these substrates, and you have so far used, for example, the ECL from Pierce, you may be happy with a SERVALight Vega substrate, for example. So you can choose the appropriate SERVALight substrate. If you're already using another substrate in your lab and you are not happy with it because of performance or price or these things. So if your substrate is not in this list, just send me an email and I will check what will be the optimal one for you. So it's no problem to get samples and to test the substrate. Okay, after the incubation with the substrate, it is necessary to do a documentation step. This can be either done by a film, where you will get a black band as a positive signal. The film is directly placed upon the membrane, only separated by some plastic film to avoid the film to get moistened with a substrate solution. And after this, you will develop the film and you will get your results. But due to the low distance between film and membrane, it is not easy to do quantification or to get semi-quantitative information from the film exposure data. So a better system is the system which uses a CCD camera, where the distance between the membrane and the detection system is a little bit wider, so this makes the quantification much easier. You will need a cooled camera for this, because due to the distance between the membrane and the detection system, the exposure times will be higher. And so, to reduce the noise and disturbance, to enhance the signal-to-noise ratio, you will need a cooled camera. And one system which is only for chemiluminescence detection is the GeneGnome from Syngene. It is a very easy system to handle, and you will get your results very fast. It is suitable for a detection of miniature plots, 10 to 10 centimeters maximum. And in the part 2 of this webinar, you will get further details about this system. So therefore, this will be continued, and further details, you will get further details if you attend part 2. So don't miss the date. Keep it in mind on June the 30th at 3:00 p.m. You will learn more about the GeneGnome and its special features for chemiluminescence detection. So if you need further information or have questions about general Western blotting, electrophoresis, this webinar, the products shown in the webinar, or in general our products, please contact me using either the phone or by email. So thank you for your attention, and now let's start the questions.